Okay. So as we were discussing earlier about homogeneous differential equations, what if we have the degree homogeneity in degree, but there is a constant added. So here the degree is 0. So there's a method by using which we can make the no make this particular function a homogeneous function, or the differential equation a homogeneous differential equation. How? What For that, what we are going to do, we are going to replace x with capital X plus h, and y with capital Y plus k, where h and k are constants. So then further on we will discuss about then dy over dx becomes dy over dx, the capital of y and capital of x. So it will be written in such a manner. So after we will substitute capital X plus h for x and capital Y plus k for y. Then we'll have this kind of equation. Now we want this to get eliminated. So this will be weighted to 0. And then we'll solve equation for h and k. Okay. So after solving for h and k, our remaining, we will have the value of h and k, and we will utilize these values later on. Then what is remaining to us is this. Then we can further go on and use the same method which we used for homogeneous differential equation, by making the differential equation in terms of y over x or x over y, and then we can solve the differential equation. Later on we can back substitute the value of x with x minus of h, and capital of y with minus small y minus of k, right? So then we'll be having our differential equation. So that's how we are going to look at things, where we have to reduce homogeneous differential equation if there are there are certain constants added. Now there can be another scenario in which a1, so there was a condition, a1 by a2 should not be equal to should not be proportionately equal to b1 over b2. Why? If it is the case, if they are equal, so we can simply put simply what we can do here, we can convert the variable of function in x plus y terms, and that will be simply solved. We have also discussed it earlier in reducible variable separable method, separable differential equation. I hope you are aware about it. Any doubts?
No, sir.
So there are two conditions in which this type of differential equation is in front of us. If a1 over a2 is not equals to b1 or b2, we will go ahead and further apply this method. Otherwise, we'll simply make our differential equation in the terms of x plus y or x minus y, and we'll consider this equals to some k plus y or something. There can be certain constants in multiple with x plus y. Basically, what is the gist of thing is, we have to make a common variable, a single variable of this particular function on the right hand side. Here, what we are doing here, further on, we will go ahead and we'll make the function term in the variables of y over x or x over y. And in variable separable method, we were doing about this. So the gist is this only. Clear?
Yes, sir.
Moving ahead, then there's an example. So what we'll do, we'll try finding dy over dx. So when this will go in the right hand direction, then it will become like this. So now this is not a homogeneous differential equation, because the coefficient of x is -1, coefficient of x is here 2, and coefficient of y is +2, coefficient of y is here -1. These are not equal. So what we are going to do, we are first going to reduce this to homogeneous differential equation. And we'll do so simply. We know that when we will put x plus h and something something, so simply there's a trick. If you don't want to uh, write these many steps, if you don't want to write these many steps, simply do equate this, like in the example solution also they have equated this to 0 and this to 0, then they have gone further and find out the value of x and y. And further, what they have further on done is that they have considered x is equals to -1 plus of u. They have not used h and k. They have used u and v. Doesn't matter. X is equals to -1 plus u. Y is equals to 2 plus v now. Simply dx is equals to du. On differentiating, we can find out that dy is equals to dv here also. So equation will be reduced to now 2x 2u minus v. After when we will put x is equals to this and y is equals to this, so the differential equation will be reduced to this. Now this can be easily made into a homogeneous. This is a homogeneous differential equation. So equation can be put it in the forms of u over v, and then we have further gone on. And after considering u upon v is equals to t, after differentiating it, we have this particular substitution. Then further on, we have reduced and we have substituted dy and dx, and now the whole differential equation is in terms of u, v, and t. Sorry, v and t and dt and dv. So further on, we'll solve this equation and we'll separate v terms with v and t terms with t, and then going ahead and taking differentiation, this will be simply becoming logarithm, and this we have to break down how t minus 2 t square minus 1. We know t square minus 1 can be represented as t minus 1 into t plus 1, right? So we'll try to make t minus 1 in the numerator part. So we can write it as t minus 1 upon t square minus 1. So when we will write it separately, so what it will become? T minus 1 upon t minus 1 into t plus 1 minus of 1 upon t square minus 1. This cancels this. So 1 minus 2t minus 1 here also. Sorry, t plus 1, and here t square minus 1 is remaining. And this will be further solved by what we have done till yet, t minus 1 minus 1 minus of 1 into t square minus 1. So there is a mistake in writing over here. Should be like this. Okay, then the formula we know about integration of dx over x square minus of a square. This is 1 by 2a into logarithm of x minus a upon x minus 2. So there is a little mistake in writing over here in the solution, and then they have to further add on logarithm of, like, we know the formula. Let me write it over here. Integration of dx on x square minus of a square. This will become, if I'm right, logarithm of x, no, first 1 by 2a logarithm of x minus a over x plus a plus c. Is this formula correct?
Mm, yes, sir. I think
Yeah.
yes.
So there's a mistake, little calculation mistake in the solution, and then we have already, after integration, we'll back substitute the value of t, u and v in terms of u and v. And after solving it further, understand the gist, understand the method. Okay. After back substituting the value of u and v, we will further on substitute the value of u and v, which in original variables of x and y. So this is now the general solution. Understood? Or should I solve it?
So could you solve that too?
Please. Yeah, please. I'll do that. So कहाँ से? So let's solve from starting, or from where should I solve?
So from starting itself.
Okay, no problem. So here is our question. So dy over dx now became minus of x minus 2y plus 5 over 2x minus 1y plus 4. So now looking at the degree of these variables, we know this have the potential of becoming a homogeneous differential equation. But there are some constants. So for that, we'll use a method. First, we will equate x minus 2y plus 5 equals to 0 and 2x minus y plus 4 equals to 0. Then we will multiply by 2 to the second equation on both sides, so it will change nothing in this. So now it will become 4x minus of 2y plus 8 equal to 0 plus 2, 0 into 2, it becomes 0 only. So now subtracting both of these equations, changing signs. So on subtracting this, x minus of 4x minus of 3x, this will cancel each other. 5 minus 8, this is 0. Yeah, so minus of 3x is equals to 3, x becomes minus of 1. Now we'll find out the value of y. From y can be written as 5 minus x upon minus 2. So 5 minus of minus 1 plus 1 upon minus of 2. So this will become minus of 3. X is equals to minus of 1 and y is equals to minus of 3. Has we done any mistake or not? 5, 5 5 plus, okay, minus 5 minus x. So this will become minus 5. So minus 4 minus 2, this will become plus of 2. So these are two values of x. So basically these are this intersection point. This is rough work. So now we will substitute x with minus of 1 plus of u and y with plus of 2 plus of v. And now on differentiating both sides with respect to x, 1 is equals to uh, du over dx because we are differentiating with respect to x. Now differentiating this particular equation with respect to y, 1 is equals to 0 plus dv over dy. So now du is equals to dx and here also dv is equals to dy. Correct? Is this clear?
Yes, sir.
Yeah, so this is this whatever I have written here is a method to find out the value of that how to which uh, it should be substituted x and y should be substituted with what. So this is just a method in which we were finding intersection point between these two straight lines. Great. So now let's substitute. Dy is dv and dx is du. And minus of x minus 1 plus u minus of 4 minus of 2v plus 5 over 2x is minus of 2 plus 2u minus of 2 minus of v plus 4. Yeah, dv over du. Now u term becomes a negative sign, becomes a positive sign. Minus 1 plus 5 plus 4 and minus 4, this will become 0. So here 2u minus v and minus 2, 4 still cancel. Minus 4 plus 4 0, right?
Yes, sir.
Now let's take u common. Minus 1 plus 2 b over u. Let's take u common from the denominator also. So this will cancel each other. And now we can spot that now the differential equation has converted itself into a homogeneous form of having a variable of v over u, right?
Hmm. Yes, sir.
Let's change color. So let v over u is equals to t. Now v will be ut, differentiating both sides with respect to t. So dv over dt becomes u uh, u into dt over dt plus that's one plus uh, t as it is and du over dt. V is equals to t. Now we had to find dv over du. So let's do one thing. Let's differentiate with respect to u because we had to find dv over du. No? That's why. So now v becomes ut, differentiating both sides with respect to u. So dv over du into differentiation of first and second term as it is. Du over du becomes d1 plus u as it is d2 over du. Now the value, this will be directly substituted by this, and v by u will become t. Okay, so it's right in the next t plus u dt over du and minus 2v, sorry, 2t minus 1 because 2, this will be written as t, 2t minus 1 upon 2 minus t minus t. So this is the differential equation. Now let's try separating the variables. That's u and t is in the scenario. So let's bring t to the right hand side. 2t minus 1 on 2 minus t. So 2t plus t square. Understood how have I written so?
Yes, sir.
Okay. Now let's bring all the term to the right hand side. Sorry, left hand side, 2 minus t on t square minus 1 to dt equals to du over u. Now the variables are separated. Yes?
Yes, sir.
So let's differentiate on both sides. So the right hand side will simply become logarithm of u plus c. Logarithm of u plus c. Okay. Let's solve the left hand side separately. 2 minus t upon t square minus 1 into dt. Now, as we know, t square minus 1 uh, is the denominator and its derivative is what? Its derivative is 2t. Yes, so simply we have its derivative in the numerator. So let's assume t square minus 1 to be equals to some no we have already used. What letter what we have not used? Let's consider on my name S. So S we haven't used, right? Right?
Yes, sir.
Yeah. So substitute, sorry, differentiating both sides with respect to dt. Now this will become 2t equals to ds over dt. Now the value of now 2t dt is becomes ds, right?
Hmm.
Okay. Okay, so let's write it separatively. 2 over dt square minus 1 minus of t upon t square minus 1 dt dt. Now t dt here will become this will be simply using the formula which we have written earlier. So this will be simply become ds over dt. this will become ds over 2 into this is what? This is s. So this is half into logarithm of s. S is what? T square minus 1, right? Yeah. Plus integration of this 2 into integration formula of this is what? 2 over t square minus 1 into dt. 2 is a constant written outside for t square minus 1. So this was a formula of dx upon x square minus of a square, where a is 1. So its formula was 1 by 2a logarithm of x minus a upon x plus a. If I am correct, let me check from somewhere. Could you check from your notes, anyone?
Sir?
Is this is this formula correct or not? Could you check from your notes?
Okay, sir, 1 minute.
Okay. 2 into 1 by 2. A was 1 into logarithm of x was t minus 1 upon t plus 1. So 2 cancels 2. Logarithm of t minus 1 upon t plus 1. Have you checked?
Yeah, sir, it's correct, sir.
Okay, cool. So its differentiation we have calculated. Its differentiation is this. So now let's add half into logarithm of t square minus 1. So now solve this. Now let's solve this on the next page. Now let's expand the logarithm. Logarithm of a over b can be written as ln of a minus b, and logarithm of ab can be written as ln of a plus ln of b. So here logarithm of t minus 1 minus of logarithm t plus 1, right? And there's a half. Are there any coefficient to this also? There are no coefficient to this. Plus of half. So it will become logarithm of square root of t square minus 1. So now these all are in addition or multiplication. Multiplication. They can be rewritten as t minus 1 upon t plus 1 into square root of t square minus 1. So this is now the integration which we have got, plus in a constant of integration. So how much we have solved? Okay, so we have solved about the integration of this, and also the right. So this we have solved completely. The right hand side was logarithm of u plus c. Um, yes, so this was equal to logarithm of u plus c. Now let's back substitute the value of t. T was u by v or what? T, where's T? T was V over U. T was V over U. So logarithm of V over U upon V plus U over U into V square minus U square upon U equals to logarithm of U plus C. Now this U and this U cancels each other, and this can be further. This can be further rewritten as logarithm of v minus u on v plus u into v square minus u square upon u. Correct? Equals to logarithm of u plus c. Now we have to back substitute the value of v and u. What was v and u? V and u. Yeah. So v u is x plus 1 is equals to u, and y minus 2 is equals to v. So this reached y minus 2 is equals to v. So now we will back substitute the value of y, u, and v. And if you are thinking this question is so long, so please don't think that this is a PYQ. This is an example of some book. So examples are normally built and made to understand, so to let you understand the value, the concept clearly. So yeah, it was. So y minus 2 is equals to v. Let's make this substitutions. U was x plus v. U was x plus 1 and y was v was y minus 2, right?
Hmm.
Logarithm v minus u. So this will become y minus x into minus 2 minus 1 minus of 3 v plus u y plus x and minus 2 plus 1 minus of 1 into v square minus u square. Oh my god. What we'll simply do is these two terms are getting multiplied by each other. So let's write like that only. Over u, it was x plus 1. Was logarithm into u plus 1. U is x plus 1 plus c. So this should be our answer. Now let's try to match the option. So which option should be correct? What is A here? A is the A should be the constant of integration, and we were considering it as C. So we will also write A as the constant of integration. So after simplifying, they have substituted it to, and we can also, so similar, our solution is also little bit similar to the what answer is given, but they have solved it wrong. So our answer might not match. So here what we can do, a logarithm of u. So we can bring the logarithm of u to the left hand side and keep the constant here. So let's make some changes over here. Okay. So now u can be written underneath it. So it will become u square then, because logarithm of a minus logarithm of b will become logarithm of a over b. So now that will be written as simply this will be square and this complete term will be gone away. Now c can be represented as logarithm also, and it's not a mandate that we write c as c only, because as it is written as a in the option, so we can do so. So y minus x minus 3 over y plus x minus 1 into integration of y plus of x minus 1 and y minus of x minus of 3. Y minus of x minus of 3 on, yeah, upon x plus 1 whole square. The square root is limited to the numerator only, in is equals to a. So now let's try matching the answer if it matches at any options. X plus y minus 1 into cube is equals to a into x minus y plus 3. Now, in such a scenario, if you are having different looking answer and like not a different looking answer, it's not a different answer, but it is just present in some other form. So what you can wittily do is that you can try put value of y and x, and that might match with any option. But as I doubt here that options must also not be correct in the question because there was a calculation mistake here. What was the calculation mistake? As they have wrongly solved the integration of this as per me, because the integration of this is correct. Yes. But I have objection here, minus of half, because t minus 2, they what they have written it in separate form. So t minus 1 and t plus 1 over t minus 2. So it can also happen they have used partial fraction method. But as far as here as we can see, because they have tried to make t minus 1 over here and they have plused 1 here. So after t minus 1, it will remain like this. There will be t plus 1 term in the denominator because t minus 1 will get cancelled. And the other term will look like this. So we are not having that much time also to solve this with other method because we have solved this question already using the formula. And note one thing also, there's one more important thing to note, that when we are solving for integration, it may happen, it can happen in indefinite integration that your answers won't match. It changes with when you change method, the answers will change. Yes, it happens. If you're wondered or amazed. Okay.
Yes, sir.
I'm not saying that answers like your option will not match. That's why in UPSC NDA, they don't ask much question from indefinite integration. The weightage of definite integration is high. And they also ask a lot of questions from application of integration where we have to find the area under the curve. And also from differential equations, they ask mostly questions from linear differential equation and of like, let me show you. From here, most of the questions are from here. Anyways, let's don't jump the it and solve one by one. So this was about homogeneous differential equation. Now what we are going to look that what if what if an equation is not present in the homogeneity form. So in that scenario, there are also some exact differential equations. So before that, let's understand what is exact differential equation and what is non-exact differential equation.
Sir,
Yes. Is my screen visible? This.
yeah, sir. Now,
Yeah. So exact differential equation. So an exact differential equation is one that can be solved by finding a potential function f of xy such that its partial derivatives. So it's a new concept to us where we differentiate a function partially. Okay. Just read and try to understand. It's not in your syllabus that much that questions will not be asked from detail from this topic, but we need to understand so that we'll be able to wrap our head around what we are going to further discuss. So if there is a function if there's a function in the form m of xy, मतलब there is a function of m, they're represented by m of x and y variables, and there's a function n of x and y variables multiplied by di. So if it is in the form of this, and when there exists a function f of xy such that the partial differentiation of f function f with respect to x is equals to m. The partial differentiation of function f with respect to y is equals to n. So what is partial differentiation? Let's take a example that the function is 2x plus 3y and plus 5. So if we are differentiating the function partially with respect to x, then we will simply differentiate the function of having x term only. We are going to just differentiate this term which is having x. So its partial differentiation will only be 2. And if we have differentiated it completely, so we'll write 2 plus 3 y into dy over dx. But it is not the case because we are differentiating the function partially. And if we differentiate this function with respect to y partially, then we are only going to look on the term which is having y. So its partial differentiation will become 3. So this is how what is partial differentiation. It's not in syllabus, but just understand because it is there in physics, right? In class level. But still that is not in our syllabus, but we need to understand. Okay, so you may not worry about this, but just, is this clear?
yes, sir.
Yeah. So let's now move ahead and hmm. So if you find such a function that the solution is given by f of xy is equals to c, where c is a constant, then the differential equation is an exact differential equation. Otherwise, the differential equation will be non-exact. A non-exact differential equation, on the other hand, does not directly fit the form where you can find such a potential function f of xy. That means if the differential equation is in this form, that it does not satisfy the condition of exactness, that the partial differentiation of m with respect to y and the partial differentiation of n with respect to x will not be equal. So in this scenario, their differential equation will be non-exact. And also to solve these non-exact differential equation, we have to multiply an integration factor with them. Okay. So it is also written here that to solve non-exact differential equation, you often need to use an integrating factor to make the equation exact. An integrating factor is a function that when multiplied with non-exact equation, it converts the differential equation into an exact equation. Clear? If it is not so clear, we are going to look for an example and you will understand better.
Yeah, example is good.
Yeah. Yeah, so we have a differential equation here, and this is a m function x and y. This is function of n. Let's name it as m and n. So we can check for exactness by partially derivating the m function with respect to y. So the terms which is having y is this and this. So simply we will, in partial differentiation, we consider all other variables as constants. All other variables as constant except the variable which is present here. Okay, which is present here. So y is only a variable, otherwise all the variables in this are constant. So when we'll differentiate this particular term, so it will simply become 2x, considering x as a constant. So when we'll differentiate y, then will be 2y. Same goes for here. So now these two are equal, so they are exact. The differential equation is exact. Okay, and we will not need to check it. Okay, as far as I understand, we'll not need to check it as per our ND syllabus, but still learn it. Okay, so further non-exact equation. In this equation, let's consider this function as m of xy. This is n of xy, and then when we'll differentiate it with respect to y, then it will give 0. And why we are doing it with respect to y only? So you can remember it that if the function is getting multiplied with x du of x, then we are partially derivating that particular function with respect to y. If there is dy, then there is del of x here. So same goes for here also, 1 plus 2y, considering y as a constant. Okay, but there is a mistake here. Y minus 0. Okay, now this is n differentiating 1 plus, there it should be 0, but there is a mistake here. So let's tell the copilot there is a mistake here. And so considering the mistake, right? So here these two results are not equating. That's why the copilot has considered that they are not equal and the equation is non-exact. So then we need an integrating factor to solve it. And what integrating factor should be used? We will discuss it later on in our slides. So I appreciate your keen eye. Let's correct the. That means the equation is exact, right? So a better example, they have provided us a different example. Now here 2x, now the partial differentiation of this with respect to x is 2x plus 3. So here they are not equal, so the differential equation is not exact. We would typically, okay, whatever. So now what the gist of this is, for non-exact differential equations, we have to multiply a integrating factors to solve them, right? Clear?
Yeah, sir.
Yeah. Let's go back to our notes. Visible?
Yes, sir.
Now we have understood what is exact and what is non-exact. So this is some exact differential equation, and let's solve them. X dy over dx minus y, separating the variables easily. So integration, this will become logarithm of y is equals to logarithm of x plus, let's take the constant in logarithm form only to for just better convenience. So this will become logarithm of x3 minus logarithm of y. It can be written as 1 by y is equals to xc, right? So it can also be written as, if we will take the constant on the left hand side, xy. So the constant can be rewritten as c dash 1 by c, considering 1 by c dash xy. So this is the solution of differential equation, right? Yeah, so let's go for the next one. This is similar. This is in homework. Do this because we have to cover the syllabus, right? This is very easy. Just you have to integrate. Take a snapshot
Okay,
and
sir.
send it in the WhatsApp group.
Sir?
And please, after doing the homework, send the picture of done homework in the WhatsApp group, Omega Maths.
Okay, sir.
Yeah, take the snapshot of this also. And then this also.
Sir, could you show the previous one?
Yeah. This one.
Yes, sir.
Or should I solve it?
No, no, sir. I was just asking for taking the screenshot.
Done?
1 minute, sir. Yeah, sir.
Done?
Yes, sir.
So these are important. These are important. The result of the previous two, third and fourth result. And these you have to remember. Otherwise, the earlier one were easy. You can just simply understand by reading also, right? So please take a note of this. Going ahead, let's discuss linear differential equation. These are non-exact differential equation. Now, in this equation, we know there's a requirement of some integrating factor, which is represented here as R, and what we generally represent, write it as IF only. So the integrating factor for the differential equation in this format, dy over dx plus p y equals to q, where p and q are the function of x, is known as a linear differential equation. And for this particular equation, we will multiply with r. R is an integration factor, which is e raised to power p into dx. Let me rewrite it to make you better understand. Non-exact dy over dx whenever the differential equation is given in this format, where p is a function of x, okay, multiplied by y is equals to q, where q is also a function of x, and it can be x also simply. So whenever there is a differential equation given in this format, so we will use an integrating factor, which will be e raised to power integration of p into dx, because p is a function of x. Or otherwise, there can be linear differential equation in terms of this also, where x and y are reversed. So here the integration factor will be e raised to power p into dy, right? Now the general solution will be y multiplied by integration factor equals to integration of integration of q, which is a function of x, multiplied by integrating factor into like the whole is in dx form plus c. We can add that later also. For this particular kind of differential equation, where the p and q will be in terms of y and the derivative will be dx over dy, y and x will change their places and nothing will happen. Okay, just remember the first one and reverse y and x from their place. You will be able to recall them easily. Simple. But yeah, you have to make sure about to learn this differential equation, and later on you can just change the x and y in general solution. Clear?
Yes, sir.
This is linear differential equation. Absorb the formula very hardly, okay?
Okay, sir.
Let's take an example and we'll be able to better understand it. Yeah, there's an example. So here dy over dx. So we know it is of the first form. Into y into there was a p. So 1 by x is the p plus y is equal to logarithm of x. So here the p is 1 by x and q is logarithm of x. So integrating factor will be in integration of 1 by x into dx, which is simply logarithm, yes, logarithm of x. So e and log will cancel each other and integration factor is x now. Now the general solution, formula of general solution was y into integration factor, integration of q into integration factor of dx. Simple. Y into integration factor is x now. Have we done any mistake or no? Y into integration factor 1 by x. Integration of 1 by x is logarithm of x. Am I correct or no? X is 2 minus 1 minus 1. Yes, yes, yes. It is so. It is so. Y into x integration of q was logarithm of x. Logarithm of x. Integration factor is x into dx. Now this will have its xy Eilert formula. This is an algebraic function. This is logarithm function. So Eilert. So the first function will be logarithm. So first function into integration of second function, which will be x squared by 2 minus integration of differentiation of first function. Yes, differentiation of logarithm of x is 1 by x into integration of second is x squared by 2 plus integration plus constant integration. X cancels x. Now there's further integration of let's write this first. Logarithm of x into x squared by 2 minus integration of x dx is x squared by 2 plus c. This would be our answer. Matching with, is it matching with the option number B? It should match with the option B, but there's a little mistake which we had in calculation. There's a 4 missing under x square. So let's recall our steps. So integration of x log x minus of integration of derivative of this. So derivative of this, no, sorry, derivative of logarithm of x, which would be 1 over x. And integration of x will be x squared by 2. That's completely correct. So let's check the solution. where we have done a small calculation mistake. Okay, x and x will be cancelled here. Integration of x. Okay. We have not considered. This is correct till here. But after that, we are further integrating x dx, and 2 was originally here. So when we will integrate x dx, there will be x square by 2. So 2 will get further multiplied by 2 and it will become 4. That's how our answer will come as B, which is correct. Is this solution clear, everyone? Any doubts? Any doubts, anyone?
No, sir.
Great. Let's take, oh no, let's not take more examples because we have one more slide left. Just one more syllabus. Just one more. So when the linear differential equation is not earlier, the linear differential equation is this, right? P of x into y is equals to q of x. But here the problem is the there is a function of y getting multiplied with p. P and q are still the functions of x. But x of y is also multiplied with p. And there is also another t of y, which is the derivative of s of y. So we can like represent it as s of dash of y into dy over dx plus p of x into s of y is equals to q of x. So now this is the differential equation of which we need to find out the solution. So for this, what we will do, we will simply reduce this particular given differential equation to linear differential equation. And how we will done so? By substituting x is equals to y is equals to z, and after putting that, then dz over dx plus p into z is equals to q. Yeah, how we have written so? Let's, if s of y is equals to z, then differentiating on both side with respect to y, with respect to y. So this will become this, and this will become dz over dy, because this was derivative with respect to dy. Okay. Then what, how we can write it further is dy now has become, now s dash of y will become dz over dy into dy over dx. So dy will cancel dy, and that's how they have written dz over dx. They missed so many steps in between. So this is become dz plus dx plus p is there, s of y is there. So s of y is z. So p is there, s of y is there, which is z equals to q. So basically now we have made it in the simpler form, and this is now the linear differential equation, where y is simply reduced, y is simply substituted with z. So this is the trick, and the remaining portion will be simple, easy. Okay. And they have given an example also. We'll discuss it later. First, let me first please tell me if the concept is clear or not.
Yes, sir.
Yes. So we have simply taken s of y as z, and the equation will further reduce to linear differential equation. Please note the condition that it is provided the differentiation of s of y with respect to y is given as t of y. Okay.
Yes, sir.
Yeah. So let's discuss one example quickly. Do everyone needs the notes of this? Should I send these PDF also of slides, or the recording is enough?
PDF would be helpful, sir. So if you send it.
Okay. Yeah, I'll do.
Okay.
So this is a solved example. Thank God we have already closed the time. So the given differential equation 2 of x of y, its derivative is given here also. So from seeing itself, we can we can observe that this is a differential equation of this format. Okay. No, this is not in that format. This is a simple example of linear differential equation. So I'll bring an example of reducible linear differential equation tomorrow. Okay.
Okay, sir.
Is everything clear? Any doubts?
No doubt, sir.
No doubts. Okay. Thank you. Good evening, Jai Hind.
Thank you, sir. Jai Hind.